This is issue 75 of the Kaiju Engine, where I'm going to be setting up the base UI code. Now, this isn't going to have any UI by the end of it, but it's just setting up so that we can make our UI on top of it. I'm also going to do a bit of cleanup from of just some various functions I need and things like that. So I'm going to start off inside of the config here. And when we're going to be doing UI, we're going to need a blank square for panels, just the baseline stuff. So I'm going to set this up as a textures const, texture square. And then this is going to be shaders. And let's see. So you'll notice that I was doing vert and frag at the end, but here I have vert and frag in the middle. So I'm just going to change that to the end just so it's uniform here. Vert and frag. While I'm here, I'll probably also, these two also. Vert, frag. I'll probably stub in the UI ones as well. Shader, UI vert is equal to shaders slash UI dot vert. And then a frag one. And then we're also going to have a 9 slice one. Shaders, UI 9, frag. And of course, this is going to be, for those of you who need a refresher on 9 slicing, it's just so you can have an image with like borders and it can be really small. And then you create essentially like a tic-tac-toe grid, and it's 9 squares in there. And it says where things can stretch, and so you can make the corners stay the same, and it looks like looks almost as if it was pixel perfect to the size that it was supposed to be because of the way they've set it up. But really, it's just stretching in a 9 slice, and so we're going to have a shader for that. The next thing is I noticed that this bitmap doesn't have .go on it. It was just bitmap. And also, rather than dealing with this this byte array, we can do type bitmap. Might as well as a byte array, and then just replace all of the instances of byte array with bitmap, except the first one, of course. And then that means that these can act as the struct functions. So anywhere we have this bitmap here, I'm just going to go through and replace it to have it in the front. Okay, I went through and did that. I just named it B instead of bitmap. Just that's kind of how I set up these member functions. And since these are coming in as a slice of bytes, I don't have to pass them as the pointer to them. So if that looks confusing to people who are using it, we can always add a pointer in there, but it's just simpler if I don't. Another bit of cleanup. These are just cleanups that I was doing when I was working on a project that uses this engine. Is instead of the create go for the project, rather than saying create new project, because then it's project dot create new project, we can just call it project dot create new here. So the next thing I want to work with is the entity. So entities are, the game objects, the thing that exists that has a transform, and just some other helpful data, and it has a hierarchy of children. So this guy does a few things. It kind of acts as this mediator almost to the things that relate to it. So for lack of a better design for now, I'm going to add in the simplest solution to binding data to this entity. So in a lot of game engines, what they do is they create these like components, and then you attach components to their game objects or entities, and then those components have updates and all these series of functions. But as you may know from seeing in the previous ones, I'm not a big fan of that. It creates very rigid, large hierarchies, and then you have a lot of derivatives and inheritance and all this other stuff that you don't need. It's just very complicated. So we go for a design where the host has an update, and then you add an update function to be updated, and that update function contains all the state that it needs, so it's self-contained. And likewise, you'll have things. Uh, you'll have events on the entity for like destroy and create and all the other stuff. Um, so that separates out all the hierarchies and makes it not needed. It makes things much more self-contained. But it would be nice to have access to an entity and say, hey, I would like to get some object that is mediated through this entity, some data that is mediated through this entity. Um, so for now, we're just going to plop one of these in. I don't really like blank interfaces too much. The void pointers in C, I was the same way with void pointers in C, but this is simple enough to make it very easy to refactor later. So we're going to start with that just so that we get things going. Also, when we create a new entity, we should be returning a pointer to an entity. That's one of the things I changed while writing my program in this engine. So let's create a named data, make that guy there. And then where's our clone function? Since we changed that to be a pointer to an entity, we can remove that. Now, of course, we should probably go through the data and see if it has like a clone, an option to be cloned, which would be an argument for making an interface with some functions in it, like a clone function. Um, but we're not going to do that right now. We're just going to have our to-do there for it, and this should return a pointer to an entity. Okay. So down here at the bottom, we're going to add in func e entity add named data key string data interface if okay. If it's not okay, we're just gonna create that slice as you saw. It's a key. The map is keyed by a string, and the value is basically a slice of that data, and we'll append it to the end of that slice. Func e entity remove named data key data. This is going to assume you have the data to be removed. If okay, let's see, name data key is okay. Go through each one. If they are equivalent, hold on, let me see. I prefer to do I like that. And then of course we have a e.named data key, those slices dot delete e.named data key I and I plus one. And of course, the order of this data doesn't matter, so we can do similarly what we did. Where was it? Inside of the updates or the rendering, where we essentially just move it to the end and then chop off the end. We can do something more along those lines as well. Of course, we should be only finding one, so we're just going to remove it and break. So anywhere I do slices delete, I'm probably going to go back and do that because I don't think we currently have any slices in this kind of context that require it to be ordered. So that's the same for like the list of updates that we make when we add update functions and things like that. Okay, and we returned. Yeah, we're just going to return all of the name data in there and deal with it. Typically, there's only going to be one. one one piece of data assigned to a key, but sometimes you may have multiples. Okay, so now that is all we need to do in the entity. Another thing that I wanted when I was, or that I added because I wanted it, was that I wanted to make it easier to create an entity. And also I didn't have an add entity function. So we're going to have add entity func host add entities. And I'm actually going to do that function there. So this is the one that I wanted, func host new entity. And this will just create the entity and also add it into the host's collection of entities that it tracks. We'll worry about removing entities later. For now, when you destroy entities, they get removed anyways. Okay, rolling on the helper function train. I also wanted a func c color as color 8. This just is so I could do c dot, and I don't have to remember to use these functions. These are just, it was just more readable, I think, when I just did c dot as color 8. So I wanted to add those, and inside of transform, now this is going to be related to the UI code. We're going to have a func t transform contains point 2d point vec2 bool p underscore, we don't need the rotation, t dot world transform. I suppose we might need the rotation at some point, but we're dealing with this as a box, like an extents. So we'll do p dot x minus s dot x times 0.5. I put x dot x, s dot x. So this is the left, and then we're going to have the right, and then the top, or what? And then we're going to do the up, and then the down. And we're going to return. Let me make sure to double check this. Now, I don't know if I want to include the absolute tangent edge, so we'll do that for now, and we can change it. I mean, no, we can include the tangent edge. It's fine. Transform contains point vec3 bool, and this one is going to be similarly. Let's see how it guessed it. Okay, cool. We got the front right because forward is in the negative direction. Cool. And I will just break up this large line to 2 lines there. Okay, some other helper functions is in the vec2. I want to have a xy int, so I don't have to manually cast to integers a lot. I can just have that casted in here for me. I'm doing some stuff that uses a grid of integer positions, but vector2 is being passed around, so this simplifies that code for that. Okay, and so of course we're going to want to add that to vec3. So I'm going to just duplicate that, and we'll just and for good luck, we'll do vec4, even though I don't really need it. And we do have a vec4 int, so maybe I can have it as vec4i, Maybe I should have an int for vec2 and vec3. Vec2i, vec3i makes sense, right? So, uh, for now, we'll just write it out uh, as vec4i then. Vec4i. And this is long enough to just be down here. Okay. Cool. I mean, these are small enough. What's the harm? Vec2i, vec3i. And then we can just vec3i.go and vec2i.go. Okay, vec3. So I'll just change this as vec3i. And this one is vec2i. Okay. Means I'm going to have to change the code I was working on elsewhere because they use different helper function, or they use the ones that we were writing. Oh, that thing I was talking about earlier where we did the unsorted removal of drawing. We haven't done that. I did that. So we're going to do that now. So we're going to need a helper function instead of drawing.go. We're going to need a func drawing is valid bool. Actually, this isn't for that. This is for when we start adding in stuff. Dot shader. If there's no shader, then we're not going to be able to draw. So that'll be our. That'll allow us to pass in blank drawing into things, and know if it is valid or anything. It should be added. So let's go fly a kite. Right here, we're going to add in a helper function just in case I want to use this shader database for its size here. Return int unsafe size of s minus shader base data start. Really, it's just the size of a matrix 4 but model. I doubt we're going to add more to this, but might as well do it right if you're going to do it at all. Okay, so now what we want to do is we're going to add in a count length of d.instances, and then we're going to say I is less than count. And whenever an instance is destroyed, rather than deleting it, because we may have many of these, could be 1,000 of them, what we're actually going to do is we're going to say d.instances I equals instances count minus 1. So we're essentially taking the last element and just overriding this one. And then we're going to subtract I and we're going to subtract count. And these are going to have to be a capital I. And then at the very end, after we've gone through to this count, we're going to say if the count is less than the length of d.instances, then we are going to say d.instances is equal to d.instances count, up to count. And so that's just going to trim off the end duplicates, essentially, that we have. So that should make it quite a bit faster when we delete 1,000 instances. We're just copying in the end element to take its place and then wiping out the ending. Very simple. Okay. I know I said this one was going to be this cleanup and the UI, but I might make this video just the cleanup and then the next one the UI. But yeah, so let's go to window.go and let's add in a few helper functions. Func w. I'm gonna have to deal with DPI at some point. I'm not gonna do it now because I have to look up the functions on each of the platforms here. Return, I think 96 is default, 96 and nil. To do actually get the DPI. Func w window is phone size, and this is arbitrary. It's probably not even correct, but we're just gonna width millimeters, height millimeters, and that is error. We don't care about there. Get DPI. We're gonna return 178 millimeters and 170 millimeters, I think, is going to be my guesstimates. Expected one expression. And WMM, comma, HMM. I don't know what it wants from me. I might be typing something wrong. ASDF. Huh. Oh, comma at the end. Func W window is PC size bool. WMM get DPI. I'm just going to return WMM is greater than 254. And, oh no, not and, or HMM is greater than 254. This is whatever. Is tablet size. Is PC size is tablet size. So we're just going to return not is phone and not is PC for that one. And then we're going to have a helper function DPI to pix, px, it's in pixels, target int, return target target times the pixels divided by is how I have it. Okay. So that's just some arbitrary numbers. And also what we're going to do is probably convert these into functions. So on Android, this will just return false for is PC size. I mean, it could, there are Android laptops and all of that now, right? That's what Chromebooks are. So maybe not. I don't know. Just something we have to tweak around with. Okay, so this video is long enough because there was a lot of stuff that I added while going and playing around and creating porting my pixel art drawing app. I needed all this stuff. So now that I have it, I'm happy. And next one, which I'm just going to do right now, the next video is actually going to be about the base UI stuff.